Hi, welcome back. Those two caps there are the replacements for those grubby melting ones that I showed you in the previous video. So as you can see, when I said this was going under the knife, that's exactly what's happened. I got stuck into replacing the components, at least the caps, and it was actually quite an easy job. The way the circuit board is set up makes it pretty easy to work on. Because you go down the bottom, unsolder the connections from the PC board, and you have access to all the components, which is pretty neat. None of that cutting, clipping, wrapping around that one needs to do with some of the other radios. So this is the first great thing about this radio. Working on a PC board has actually proven to be a lot easier than I thought. The FM section has had nothing done to it yet because it has none of the damaged caps, but as you can see, the others have been changed. The yellow ones, that orange one is a 47 nanofarad one. I didn't have any more of the yellows, so I put that in temporarily. Maybe I'll change it later, just to make it look the same. And here's the parade of sorry characters. There isn't one in there that's held up. They were all completely knackered. And the values are amazing. In some cases I got 20-30 times more capacitance in measuring with the meter than the rated value. So they were totally useless. And this is not even looking at the leakage, I'm just looking at the capacitance value. So they were completely gone. As you can see, we had some pretty interesting melting going on there. And this is why I did something which I don't normally do. I decided to replace them all before I did any testing, and before I even considered the power up, because they were so bad. I was worried that if I just did the usual, which is start with the power supply and test the power amp, ignoring the rest, I was afraid that one of these guys in the up the circuit further up line would have caused some major problems. So I replaced them all, and now we're ready for the first power up. So what I've done is I've removed all the tubes, or the valves. I'm going to do a soft power up with the lamp limiter. Basically what I want to do is check for voltage, check the heater voltages, and make sure we're getting voltage out of the Selenium rectifier, and more importantly make sure that nothing goes up in smoke on the first power up. And we're going to leave it active, put in one 40-watt bulb, switch it on. We've got 220, 230 volts on there. And now it's time to switch on the radio. I'm going to hit the FM button, and that brings power to it. We'll see what happens to the voltage over there in the lamps. Okay, here we go. I have the 220 volts is still there. The dial lamp has come on. And it seems, well, there's no current being drawn because the tubes are out. But we don't have a short. Okay, that's good. That's good. Let's check some voltages. I have the meter connected to ground, and I'm going to check the output of the Selenium rectifier, which goes to the first filter cap. So I'll check the voltage on the first filter cap. $334. Okay. It's a bit high, but obviously because there's no current being drawn, that's probably to be expected. Let's look at the second filter cap. 332 makes sense. Very little current being drawn from one stage to the next. Third filter cap, 331. Same story, very little current being drawn. So we have B+ coming out of the filtering systems. What I need to check now is I'm going to check the heater voltage. AC volts, let's see, it's between 3, 4 and 5 on all these tubes. Seven volts, that's it. 7, strange. Seven volts. 7 volts. Go back to that first one. 6.99, 7 volts, okay. 4. 6.99, 7 volts, okay, that's good. So we've got 7 volts instead of 6.3. All the tubes, I haven't tried this one, 1, 2, 3, 4. It's ground. 7 volts, right. All the heaters are 7 volt AC. Again, it will make sense. There's no current being drawn, so the voltage is going to be slightly high. What we want really is 6.3 when all of them are drawing power. The good news is that nothing's blown up. Nothing's smoking. I have B+. It seems high. Obviously, it's high because there's no current being drawn. Just so you know, it should be 260, I believe it says here. 265. So what I'm going to do now, since we've had no blow-ups, is I'm going to put in the tubes and we're going to do this again. Right, so I've got all the tubes in and I have left the FM button selected. So when I push the on button here, I will get the power going to the radio. And I'm going to leave just the one lamp on. And let's see how we go. Okay, here goes. Okay, that light lit up slightly. That's the 40-watt lamp. Then it dimmed, which means that that's to be expected. So the power started pulling power and the current drops. The charging capacitors now, we're getting it going up again. And the voltage drops. No short though. Let's see what happens when we give it another 40-watt lamp. Voltage goes up. There's no short in there. Give it another one. So we're up to about 210 volts. That's nearly the top, which is 235 in my case. I have the dial lamp on and I'm almost afraid to put the volume up. Okay, so I have the dial lamp on. We can see the radio's on. The limiting is active. It's at about 210 volts. And I have a speaker connected. And I'm going to put the volume up and see if we've got anything. Well, I can hear something. I've got something. That's on FM. Let's try shortwave. Definitely have something. I've got no antenna on, so I don't expect much, but medium wave. Aha! Medium wave uses the ferrite antenna at the top there, which I can activate and deactivate with this push-pull. So ferrite antenna on, volume up, medium wave. Let's see. I've got something. Brilliant. Ha. Right, I can pick up the 1 AM radio station, or medium wave radio station that we get in Madeira. Whoop-de-doo. So, medium wave's working, the audio amp is working. See if I pick up anything else. Picking up something else, probably from Canary Islands. Yep. Spanish, so it's Canary Islands. Okay, medium wave's working as well. Long wave, I should get absolutely nothing at this time of day, and here. But I do have the noise. Okay, that's great. Alright, so what have we got? We've got sound. So the audio section is working. That means the L84 is not blown. We have long wave, medium wave, and short wave noise. In the case of medium wave, I'm actually picking something up. So the ferrite antenna circuit is working. That's activated with that push button. Short wave is making the right sounds, but there's no antenna on, so I don't expect much. And FM is making the right sounds. Again, no antenna on, so I don't expect much. But it seems that all the circuits are working in various degrees. We'll find out just how well soon. But now at least I'm prepared to give this full power and do some voltage measurements. I'll put the volume to 0. And I'm going to bypass the... I've just bypassed the lamp limiter. Let's see what voltages we have here. That's on AC. I want to see what my heater voltage is. 6.4, not bad. Okay, I'm measuring the lamp dimmer voltage. It's the same as the heater voltage. Now I'm going to check the B+. So now we've got power on. The voltage should have come down. What have we got? 270, and it's on, let's put this on FM. 267, 268. All right, that's the B+ on the first filter cap. 230, B+ on the second filter cap. 225 is the plus on the third filter cap. So we'll go and look at the schematic and see what we should have there. Let me just do something else. Let me measure the ripple. I didn't hear any hum. So putting it on AC, what ripple have I got? 3.77 volts on the first filter cap. That ain't bad. I think the filter caps don't need restuffing, which is good news because I hate doing that. So far, so good. We have B+ coming in. We've got very little ripple. We have all the filter caps responding nicely. Different voltages. We'll just check that they correspond to what we want from the schematic. We have the right heater voltage, close enough. We have the ferrite antenna circuit is working. The audio circuit is working, which is great. So let's have a look at the schematic and see what's been done so far. Right, so what we've got so far, and this is a follow-on from all the restoration, the checking that I've done and the replacing that I've done, I'll show you where we've got to and what the results are. We have power coming in here, 220 volts. In this case, it's actually 235 coming in here. There's the power switch, which works, checked it. The fuse works, checked it. Connected to the 220 in for the power transformer. This capacitor, this is that safety cap, was replaced with a proper safety cap. This output here is the 6.3 volt AC for the heaters. That's obviously working. We've checked the heaters, and we see that the dial lamp is lighting up. That's that over there. Then we have a voltage coming out here, which is resulting in a positive B plus of 268 volts, measured again just now. 268, and it's supposed to be that top one, 260, I believe it says. So we're damn close, real close. 260 over there. Okay, so far so good. This goes up there, and then we get it going to the filter section. So that voltage comes up there to the first filter cap over here. This is these three filter caps that are together. It comes to here, gets filtered through the first one. This is in that can. So 268 volts as opposed to the 260. Great. It goes into the the output transformer. That then goes out through the output transformer, and it becomes the B plus on the EL84 pin 7. It also comes through part of the the output transformer, in the form of which acts as a bit of a choke, through that 1K resistor, and it goes back to the second filter cap, which is another 50 microfarads. We have 230 volts there, and according to this we should have 224, so close enough. 6 volts off, not bad. That then goes off to various parts of the circuit, including there we go, including this grid of the output valve. So through a 1K resistor, which was checked as well, and it goes to the output valve. Then we have also from here, that comes back to the third filter cap, which is 4 microfarads, and we have 225 volts there. We should have 215 volts on FM there, so that's great. That's close enough again. So this whole filter section is working well. We know that the power transformer is working well. We know that the output transformer is doing its job. We also know that the output valve is doing its job, because we're getting sound coming out, and it's not, well, we don't know how distorted it is, because it doesn't really have good audio coming out of there. Now, what I've done here is I've checked every single component in this stage, and the results have been exactly what I got, or similar to what I got on the other Graetz. The resistors are as near as damn it what is stated here. Some of them are absolutely exactly the same value that is rated here. It's amazing to see a 47K resistor reading 47.000. You know, it's exactly on. And these Graetz do seem to have very accurate resistors that have held their value over time, contrary to most of the other radios that I've worked on. And so that's great. That's perfect. I do check every single one anyway. And I've made a list which might be interesting to look at the end of the actual values that I've read on every component that I've gone through here. And I mean every component. So this whole section has been checked. The capacitors obviously were the ones that were in pretty poor shape. They were practically all changed, with the exception of some of those little flat ones, the ones that normally hold their value exactly. I can't remember their name now. I think they're ceramics actually. But the others, the paper caps, have all been changed for polyfilm. Their values were completely out of the range. They were completely wrong. Some of them were 10, 20, 30 times their value. I didn't even bother measuring leakage. I know they're leaking like mad, so I just replaced them all. One of these, this is the cathode bypass cap. This one is an electrolytic. It's 50 microfarad. This one was reading something like 450 microfarads. It's a low voltage cap, so leakage is not really the problem, but it had been burnt by the proximity to the EL84, as I showed you in the previous video. So all this power section is working, and the power supply section is working, the power amp section is working. All right, so what I've done now is I'm preparing the signal generator, and I'm going to put in a tone into here. I'll be doing it through a capacitor just to make sure we don't get any DC playing around here. I shouldn't have any DC because this capacitor blocks it. That cap blocks any DC. I should have 0 volts DC over here. There's a 1 meg reference to ground. There's a 1K grid stopping resistor here, so there should be no DC volts. But I'm going to put it through a big capacitor anyway. When I say big, probably, let's see what I've got on hand. 1 microfarad. Okay, good enough. So that signal, it's going to be a tone, let's call it 400 or 500 hertz tone, will be coming in here. And if this power amp section is working well, the biasing and the tube and the B plus and everything else, we should get a tone coming out of the power amp. Now, I have the audio coming into the power amp section through this cap. So I'm going to put the volume control, which is behind here, I'm going to put that down to 0, just so that I don't have any interference with this tone. And the sound might actually drain through that, but we should get a decent enough tone on here to hear it. Okay, so we've set the signal generator to 500 hertz. I'm going to set the amplitude to about, let's call it 1 volt RMS. We'll see if we need more in a minute. It's output 1. I have the output 1 going through there, going through that 1 microfarad capacitor. It then goes into that point that I mentioned on the schematic, into the power amp stage, power amp tube. So now it's coming into there, into the power stage. I have the radio turned on now, and I'm going to hit the activate on the signal generator. There we go, we've got it. Perfect. Let me reduce the amplitude on the signal generator. That's it. So basically this is acting as a volume control. I have a pretty good signal coming out of there. As you can hear, actually very clear, it doesn't seem to be distorted at all. Brilliant. Let's see what it looks like on the scope. Okay, so here's the signal. I have the negative of the scope just connected to the chassis, so it's a little bit noisy there, but we seem to have a very good signal here. This is straight across the output of the speaker. I have very noisy fluorescent lights in here, so I expect some of that crap to go through. Let's try a bit more volume. Yeah, looks good. Looks good. Let's just try something here. This is not really a great indicator, but this is the FFT function on this little scope, which is really poor, but I'm looking for distortion. That would be the second harmonic distortion, and I don't see any. I don't see much distortion at all. There are a few noise artifacts coming from the noisy environment in here with the fluorescent lights and everything else, but I think we can honestly say that EL84 is working very, very well, and so is the output transformer. Great stuff. No clipping. Mind you, it's probably still on very low power. 1.3 volt peak to peak across the speaker. Get that down before I scare the neighbors. Great, so I'm happy. I'm happy. Time to move on, or move back through the preamp circuit. Make sure the preamp is working well. We'll very soon be ready to put in a signal into the phono input and see how well this works just as a pure audio amplifier. Okay, bye for now.